Okay, this will be 6.2, the unit circle and the trig of real numbers. This will be day number 2. In day 2 video, what you're going to see is how to determine whether a trig function is going to be positive or negative in certain quadrants. Remember yesterday we talked about your simple trig chart. Time to put your simple trig chart into action. You will also see the beginning of how to build what is called the unit circle. Okay, so we're going to learn about the 4 quadrantal angles, and we're going to talk about the unit circle, so let's kind of get started. All right, so yesterday you learned about a simple trig chart, what it is, how to use it, and how it functions. So today, I'm going to ask you to apply it. Take these 3 problems that you have here and tell me whether they are simply positive or negative. Okay, so all I want to know, positive, negative, and that's it at this point. So for number 1, sine of 210 degrees. Obviously, the first thing I'm going to do is figure out, well, where the heck is 210 degrees? Okay, so 210 degrees is right there in the 3rd quadrant. So if I think about my simple trig chart, a simple trig, so it's in the 3rd quadrant. The T is the only thing that is positive in that quadrant. So I know when I do the sine of 210 degrees, and if you want to check and do that in your calculator, guess what? You're going to get a negative answer. Okay, so second one. Tangent of 3 pi over 4. So again, let's draw it. Let's figure out where 3 pi over 4 is going to be located. So you should be able to say, okay, that's 4 pi over 4, so 1 less is 3 pi over 4, meaning I have to be in the 2nd quadrant. Using my simple trig chart, sine is the only thing that's positive in the 2nd quadrant, so I know this answer has to be negative. Last one, number 3, cosine of negative pi over 3. Okay, so let's think about where that is. Negative pi over 3, well, 0, negative 3 pi over 3. So I know it has to be in the 4th quadrant using my simple trig chart. It's in the C, it is cosine, so I know this answer must be positive, okay? So good idea when you have to actually solve these start to finish. It's probably going to be a good idea to figure out whether it's going to be positive or negative before you even start. I know it's where I always start just to make sure my answers match. Okay. So, all right, here we go. Unit circle. We're going to start building it slowly. We'll start with these 4 points that are located right here. If you think about it, unit circle, when I talk about the unit circle, unit is represented by the number 1. So in the unit circle, that means the radius must be 1. Okay, unit circle radius is always 1. Okay, so with understanding that the radius has to be 1, I think I know the coordinates of those 4 points. Let's see how you do. Do you understand? Take a look at those 4 points that I put there. Do you understand why they are the way that they are? Well, if you think, if the radius has to be 1 unit away, I know that this distance from the center to any point on the circle, I know that that distance has to be 1 unit away. So 1, 0 would make sense for that point. 0, 1, right? Radius is 1. Radius is 1. Radius is 1. Radius is 1. So understanding that, okay, I understand what those points mean now. Well, I also know what their degree measures are. Well, if I start at the initial side, right, if I start at the initial, I know that what happens is I start here, which means I start at 0 degrees. I start traveling in this direction. That's 90, 180, 270, and then all the way back around should be 360 degrees. Okay, so now I know them in degrees. I believe I also know them or can figure them out in radians as well. Okay, so what I'm thinking, 0 is 0 radians, pi over 2 is 90 degrees, pi is 180, 3 pi over 2 is 270 degrees, and then all the way back around is 360 degrees. So far, when I build the unit circle, I know this thing should look like this. Going to be important that you understand those. I don't think that they're that difficult to this point. I'd probably slap this thing in the front of my notebook, understanding that I should probably draw it big enough because eventually I'm going to put more lines in here to kind of build the unit circle a little bit more. So far so good. Well, if I think about the unit circle, I usually understand that to find the sign based on a circle, I take y over r. Well, if I know the radius is 1, though, I know the r value will be 1, and therefore, in the unit circle, the sign will always be the y value. Think about that. As I keep going, I know cosine is x over r, but if the radius is 1, x over 1, that would mean the cosine in the unit circle is simply just the x value. And then to find the tangent, same deal. We take y over x. So hopefully you have your graphing calculators out. I want you to try, watch this. If I said to you, I want you to type in your calculator the sine of 90 degrees. What is that answer? Well, the sine of 90 degrees, I don't have my calculator out, and I promise you I'm not cheating. I know the sine of 90 degrees is simply, the answer is 1. How did I know that? Think about this. You understand that the sine is the y value. I know this is the y value at 90 degrees, and therefore the sine of 90 degrees is 1. See what I did there? Let's do one more so you can kind of get an understanding. What if I asked you to do the cosine of 180 degrees in your calculator? What does that equal? Well, I bet you got -1. Why did you get -1? Well, I know that cosine is the x value. I know that at 180 degrees, the x value is -1, and therefore the cosine of 180 degrees is -1. Okay, so hopefully you're picking up on that. Any questions, comments, concerns? There might be some concerns at this point. Please just let me know, and good job.